The subordinate zeta function of mod 4 can be obtained by the binomial theorem of the zeta function, and the subordinate zeta functions 4, 1 plus 4, 3 is an odd zeta function, and the subordinate zeta functions 4, 1 minus 4, 3 is an odd eta function. The Dirichlet character of mod 4 does not have a primitive character, but it can be inverted by the functional equation. Again, the trigonometric function can be eliminated by the inversion of the gamma function, and it has the same form as the inversion of the L function. If the odd zeta function is inverted, it is an eta function, which is expanded into a negative even zeta function, and if the odd eta function is inverted, it is expanded into a negative odd zeta function. The eta function is a zeta function of 1 minus 2 to the power of 1 minus s. And the first term of the expansion of the negative even zeta function is also a zeta function of 2 to the s power minus 2. So if the first term is moved to the eta function, the zeta function can be inverted. Therefore, 1 over 3 minus 2 to the s power minus 2 to the power of 1 minus s is multiplied by the inversion of zeta function, and the zeta function is also expanded to the negative even zeta function. Therefore, it is obvious that the zeta function becomes a trivial zero at negative even numbers. At s equals 0, the inversion of eta function is 1/2, but the inversion of zeta function is 1 over 3 minus 2 to the s power minus 2 to the power of 1 minus s, which becomes infinite, but converges to minus 1/2 due to the trivial zeros of the zeta function. At s equals 1, 1 over 3 minus 2 to the s power minus 2 to the power of 1 minus s is infinite again, which is the same as the pole of the zeta function. The zeta function for even numbers can be obtained. The zeta function for odd numbers corresponding to the trivial zero has a convergence value and converges to Apres constant at s equals 3. The inversion of the zeta function is established in all regions, and the non-trivial zero of the critical line can be found. It is the same as the non-trivial zero of the zeta function shown so far, and even the negative zeta function of 70 terms shows an error of more than 8 decimal places. The inversion of the odd eta function is the expansion of the negative odd zeta function for minus 1/2 to the s power, plus 1/2 to the 2k power, just like the inversion of the L function of mod 3, and the alternating sum of the negative odd zeta function is multiplied by 2. Therefore, the inversion of the odd eta function is the same as the inversion of the L function. The trivial zero of the zeta function at the negative even number becomes the trivial zero of the odd eta function at the odd number, and the infinite sum of the negative zeta function at s equals 0 is equal to 1/2. At s equals 1, zeta of 0 equals minus 1/2, so it is pi over 4. Therefore, the odd eta function for odd numbers can be obtained by the zeta function. The odd eta function of even numbers for trivial zeros has a convergence value by the pole of the zeta function and converges to Catalan's constant at s equals 2. The inversion of the odd eta function is established in all regions, and the non-trivial zeros of the critical line can be obtained. The non-trivial zeros of the inversion of odd eta function are the same as calculating the non-trivial zeros of odd eta function, and even with the negative zeta function of 70 terms, it shows an error of more than 8 decimal places. When calculating the inversion of the odd eta function with the zeta function of 800 terms using Wolfram alpha, it is more than 40 decimal places. The negative odd zeta function term of the inversion of odd eta function minus 1/2 to the s power plus 1/2 to the 2k power obviously affects the non-trivial zero, but it does not create the non-trivial zero by itself. And the non-trivial zero is created by the alternating sum of negative zeta function. In the inversion of gamma function, the alternating sum of negative odd zeta function and the alternating sum of negative even zeta function are symmetrical by trigonometric functions, and at s equals 1/2, cosine and sine become equal to pi over 4. This means that not only is the functional equation symmetrical about the critical line, but the negative odd zeta function expansion and the negative even zeta function expansion can be symmetrical about the critical line.